So good to see you all here. Thanks for sparing your time for this session. Hopefully, you'll walk out with a good sense of some of the challenges that we see as important as agentic collaboration becomes more and more prominent. And some of the work that we're working with a whole consortium of industry to address that. So hopefully that'll be educational from that lens. Just to introduce myself, I'm Tushar. I lead product management for Outshift, which I'll talk about in a second. It's one of the incubation groups within Cisco. I have about 15 years of experience in product management, both across large companies and startups. And my journey into AI started at AWS, where I led product management for their computer vision suite of services. So good to be here with you all. Outshift. So want to kind of quickly talk about what Outshift is, because that will kind of give you the context for why we are working on this area. Outshift is Cisco's incubation team. We work on delivering what's next for Cisco in emerging technology areas, in adjacent spaces that make sense for Cisco businesses to get into. And in service of that, we look at a vast variety of areas and technology innovations, which then find its way to Cisco through the various products, be it existing portfolios or be it new portfolios that we can set up as in pursuit of customer success and so on. So let's start with sort of some of the setup here for why you sort of need to think about the entire space of agent collaboration and agent interoperability a bit differently than perhaps we have looked at in terms of how microservices and VMs have collaborated in the past. The biggest difference is that these agents are supposed to have agency, right? And in service of agency, you can't really apply the same deterministic formats that were applied to deterministic software collaboration. Inherently, there is a requirement for these agents to be able to understand, react, and sort of modify the way they are approaching a collaboration with another agent relative to what we used to see in the deterministic world. So we need to sort of think about what does this move from the cloud computing, which is currently largely in the deterministic era, looks like when you get into the non-deterministic part. So we know that a lot of the tasks that are going to be required of agents and multiple agents are going to need agentic collaboration. If you approach this from a user lens, if I need to get a task done today on, let's say, my own work, as part of my own work, I probably am looking at various different tools and applications that I need to do that work across. And so it's hard to hardcode it, hard to make it deterministic if you want to unleash the full promise of agents. And so we think that agents will absolutely need to collaborate, because a lot of tasks that will be given to them would be, would require different patterns of collaboration. And we know that these agents, like the example I gave, will come from various different vendors. They will use different development frameworks. They'll be built on different clouds. They'll have different identity providers. They'll belong to different organizations. And they'll have different profiles and personas, which will all have to be dynamically adjusted depending on the task at hand, right? And so we think that there is a need for a new internet, and we like to call it the Internet of Agents, where we have the ability to blend some of the software-like capabilities of agents, where agents are fast, they can scale massively, but also some of the human-like attributes of agents, which are in the sense of the dynamism, the agency, the ability to reason, the ability to understand what the task at hand is, etc. And we think that this internet of agents is where Cisco, as such, and all the industry players can play a huge role, just like Cisco played a huge role in standardizing the stack for the internet of the web era, right? Which is you create sort of a series of standards and protocols that enable these systems to understand, collaborate, discover, and identify. So just like DNS works today, you have a URL, you have and it sort of is able to map it to wherever that web is hosted. How do you build the ability for an agent to be able to discover other agents, trust them, identify them, make sure that they are doing their work in adherence to the policies that are required in that moment? How do you make sure that these agents can talk to each other? And this is where I was actually doing a search on Perplexity onto how to explain that in an easy way. And the example that Perplexity gave is, let's say there are 4 kids that are collaborating on building a house. Right now, if these kids are collaborating on building a house, it's very much like what these agents would need to collaborate on. So you need to understand what the house looks like, to understand, where if one kid puts a block in one place, the other kid has to react to that and put the block in another place, and so on. So APIs, for example, traditionally don't have that level of flexibility, right? It is more of a request response pattern, versus agents require the ability for other agent to interrupt, to course correct, to clarify. And it's a lot more chatty interface. And that's an example of some of the new aspects which A2A is looking at. For example, we had a protocol called Agent Connect protocol. So there's a need for innovations that are required on how can you enable these agents to communicate with each other that are over and above what an API can offer today. And then lastly, it's a loop. You have to be able to observe and evaluate how things are going and then react, right? So there's also a need in this multi-agentic, multi-vendor world, multi-environment world, for these agents to be able to collaborate with each other, to observe it in a sort of unified, holistic fashion, and figure out what the next iteration needs to look like. So to address this, we sort of looked at how should the OSI model be enhanced, right? And so I think all of you are sort of familiar with the OSI model. It's served us very well so far. You've got the physical data network and transport layers at the very bottom. You've got the session, presentation, and application layers at the top. But we think that there is now a need for syntactic and semantic alignment that can enable this agent-to-agent collaboration. And so we had the internet era that was more focused on VMs. We had the cloud era that was sort of more focused on microservices. I think we think that we need an internet of agents, the next layer on top of that, that deals with some of the syntactical things like MCP, like A2A, but then also enables the path for some of the semantic aspects, which is, how do you, for example, take a user request and break it down into what permissions will this request require, and make it a part of the plan, not an afterthought, right? How do you make a plan for your agentic collaboration in the sense that it incorporates some of the semantic understanding of the task itself? And that's what we've been focused on. So we announced this initiative earlier this year. It's called the Internet of Agents. And we are focused on making sure that this Internet of Agents is an open, interoperable internet for agent-to-agent collaboration across, wherever these agents are getting built, right? So let's get into some of the details on what this initiative is all about, and then we'll get into some technical details on, what are some of the components and pieces that we've been working on so far. So this initiative was called AGNTCY, and it's not a misspelling. This is what it's actually called. The E is deliberately missing. It's now a Linux Foundation project. It's an open source project where over 75 startups have participating and are participating in enabling this multi-vendor, multi-agentic collaboration, framework and standards that are required across, various suites of capability. The formative members who joined us in this initiative are obviously we played a role in Outshift in kind of driving this, but we also had team members from Dell, Google, Oracle, and Red Hat who have joined this effort with us, and we invite all of you who are interested in contributing to this initiative in the open source to enable the same kind of flexibility and interoperability that we have with the internet today in the agentic world to come and join this, and we'll share some of the details on how you can do that subsequently. So let me do a quick question and answer here, just sort of show of hands. How many of you are actually working on multi-agentic apps at this point? Any hands raised? Okay, cool. And anyone who is currently looking at multi-agentic apps that do require cross-vendor multi-agentic collaboration? Okay, great. So some of you. So I think that's great because we are then working on this at the right time, and so hopefully some of these standards can help that journey, make that journey easy for you as we go along. So let's look at what are some of the components that we are working on, right? So there are 4 main aspects, and this kind of flows from some of the things that we talked about earlier. As to what are some of the challenges that you can encounter when you have multiple agents that are from different vendors trying to collaborate with each other. The first is agent directory, right? So when you have a task that is given to an agent or a composer of an agent or an orchestration agent, the first thing that it would need to do in due time when you have these tasks that are not sort of predetermined would be to go find other agents and understand the capabilities of those agents. And so you need the ability to describe an agent in a way that any other agent can read and understand, right? And so today what you have is, all of these agents are being described in their own vendor specific manner. How do you really get to a standard, framework, which we have launched called OASF, which is Open Agentic Schema Framework? How do you describe an agent in a consistent way so that different agents can discover them, can learn about their capabilities, can learn about how to invoke them, can learn about how to configure them, and so on. So agent directory takes OASF as the base, and it enables you to set up a decentralized agent registry model where agents that are in your enterprise organization and hosted by other organizations, be it a vendor or be it other enterprises, have a way to discover each other in a decentralized way, to understand each other and collaborate, right? So that's the focus of agent directory, and we'll talk about that in a bit more if I have time. Agent identity. So the same issue comes up when you have multi-agent collaboration. How do you, so you have one agent that is using a particular IDP, which is an identity provider. You have the other agent that is using another identity provider. There's one agent that is capable of doing 10 tasks. The other agent is capable of doing 5 tasks. When they engage with each other, what tasks should you allow them to do, right? What tasks, how do you make sure that these different IDPs are still, able to you're able to sort of sort through that and get these things to interact. So that's what identity focuses on. Messaging is the 4th component that we are actively focusing on, which is more focused on when you have these agents ensemble, so you have 5 agents, 10 agents, how do you enable the messaging of this agent to happen in a lot more secure and efficient way? And here we are extending gRPC to make it more publisher subscriber oriented, while also bringing some elements of inbuilt security so that the overhead that is currently associated at large scale multi-agentic communication, both for, let's say, agent to agent or for agent to tool, can also be addressed. And we'll talk about that. We call it SLIM, which is a secure, low latency, interactive messaging protocol. And that's what we are working on here. And then finally, observability, right? Which is how do you make sure that you can generate traces regardless of which platform the agents are running on, that you can generate multi-agentic metrics that tell you how this agentic multi-agentic operation is running. And then lastly, we are doing this in conjunction and in collaboration with other open source initiatives such as MCP and A2A. And so you will see as we go along in this, a little bit more technical, that directory, for example, is able to host MCP records. It's able to host A2A records. Slim is able to have A2A messages go over Slim and MCP messages over Slim. And so we're trying to sort of work with the industry here to make sure that we're defining standards that are interoperable, not just between the agency project or within the agency project, but also across multiple projects that are out there. I want to check how am I doing on time. Okay, cool. So this is what the architecture looks like at a high level, right? So you have the 4 phases that we are really sort of focused on right now. The discover phase, which is how do agents discover each other. The compose phase, how do you then bring them together and get them to do a task. The deploy phase and the evaluate phase. And so if you look from the top to the down, you'll see that the agent directory is really focusing on the discovery phase. And you can think of agent directory as a decentralized service where these agent records are available in the standardized format, which we call OASF. And what agent directory allows then is a decentralized syncing of this, but also a secure ability to sort of have lineage in terms of when these records were created and who is the rightful owner of that record, etc. Then you come down into the diagram, you see the agents that are collaborating, and we talked about the semantic and the syntactic layer there. You got A2A and MCP that are sort of more focused on the syntactic part of it, which is how do you make sure that the agents have the right endpoints that can be used to invoke each other. But then also the Slim layer at the bottom, which enables these MCP and A2A messages to be sent to each other in a highly efficient, secure, low latency fashion. So with that, I think I can probably skip to, I did have some more slides on the details, but let me kind of skip through a quick demo here. We do have a booth at the Cisco booth area. You can see this demo at the booth. It's a multi-agentic application which simulates a coffee farm. And a buyer wants to come and buy coffee, and there are multiple agents that are involved in that. And those agents are currently built using LangGraph. They collaborate with each other using A2A as on the agent-to-agent interaction, and they collaborate with an MCP tool to check the weather, for example. So what we show in this demo is the ability for these agents to communicate using A2A over Slim, both in a many-to-many format, but also in a request-reply one-to-one pattern. And so you can kind of see how Slim enables this many-to-many and one-to-one collaboration. We also show agent identity and how we are using that to verify the permissions of what an agent is supposed to do or is able to do. And then we kind of have the observe portion integrated so that you can see what the traces look like. How did the request response emerge for this particular application? So let's see. So let me go into the demo here and show that to you. So hopefully this can play okay. So what's really happening here? Hopefully you can read this on the top left. So the first question that so there are 4. As I said, there are sort of 4 agents. So there's the buyer agent, and there are sort of 3 countries in such. There's Brazil, Colombia, and Vietnam who are able to supply coffee, and there's an interaction happening between these the buyer agent and these multiple sub agents to serve the request that the user has. And what you see here is that this interaction is happening. A2A is how these agents are talking to each other, and Slim is the common layer over which this communication is happening. There's also an MCP server that is connecting the Columbia agent to a weather app, right? So that it can use that weather information to provide information on whether I'm able to supply some quantity or not. And so the first question that this buyer agent asks is, what is the latest global coffee inventory? And in this case, you'll see that even though the Brazil agent is not sort of validated per se, it's not validated to perform an action, but it's validated right now to perform, provide information. And so in this case, if I play it forward, you'll see that when the request goes through, it Slim makes sure that all of these agents who have subscribed to this particular topic were able to get the message at the same time. And then the Columbia agent also used the MCP server, and then they all sort of got together and responded the response back to the buyer. Right. So that's sort of one example of how you're doing sort of a many-to-many publisher-subscriber pattern. Now you'll see how you can do a request-response pattern over Slim. And so let's say the question here is, can I order 500 pounds of coffee from Colombia at $5 a pound, right? And so in this case, it specifically called out Colombia as the agent that it wants to use, and Colombia was validated in terms of its identity to provide this response, and so it goes ahead and creates an order for it. Right, and now you'll try doing the same exercise with Brazil. In this case, because Brazil has not been validated for the identity for sort of performing an order function, we are able to do sort of like a tool-based access control here to say no, right? Like, hey, Brazil has not been validated, and Brazil cannot help you with this specific request, right? So, so that's why I wanted to show you. With that, I think we are up on time. So if there are any questions, oh, actually, I do want to show you one more slide. So you can sort of scan some of these QR codes to learn more about agency. We really invite you to come join us. This is an open source initiative. The more, the merrier, the better in terms of representing all your interests, making sure that it's done in a neutral way. And we also invite you to join some of the working groups that we have set up on these topics. So if you're interested in identity or Slim or Observe or directory, you can come in and start joining these working group meetings and participate in that. Also, please check out the Cisco booth area to see this demo and have a more detailed technical conversation on that. So with that, thanks a lot for your time. Hopefully it was educational, and I'm around in the corner here if you have any questions for